Alright guys, so we are going to do exercise number 2. I wanted to create a separate video for exercise number 2. So in this video you'll find all the information about how to write a kernel module, how to load that kernel module using the APIs, and how to remove it when we are done using that kernel module. So this is the exercise we are going to do. I have already booted into my Ubuntu. So I will open terminal, and before we dive into exercise number 2, let's see what current kernel modules are available and how to perform some actions on those kernel modules. We have different commands for our kernel modules that are built into Linux, so we can use those commands to work with those kernel modules. So before we actually create our own kernel module, let's see what other kernel modules are available and where they are loaded, how we can remove them, how we can reload them, how can we find more information about those kernel modules. Now in order to list all the kernel modules, there is a command, it's called lsmod, which is list module. So it will load all the kernel modules that are available in the kernel right now. So these are the name of all the kernel modules, along with the size, and the size is in bytes, and then used by how many programs are currently using these kernel modules. So this number depicts that. Then in some of the kernel module you can see that they have some name of some other kernel module, which means that these they are dependent on these kernel modules. So you can see there is a long list of kernel modules. They are currently running for me inside the kernel, so they are inside the kernel. What we can do is we can find more information about these kernel modules, or if we want, we can remove some of these kernel modules from our kernel, and we can load our own kernel modules. We can load currently available existing kernel modules in the kernel mode, in kernel as well. So let's do that. Let's remove one of the kernel modules from here. I'll use LP, it's a line printer, since I do not have any printer installed with my computer right now, so it's safe to remove that kernel module from my kernel. So in order to remove a kernel module from a kernel, you use a command rmmod, but you need root access to do that. So let me do it without that, and you see what happens over here. So it's showing that this operation is not permitted, which means that I do not have sufficient permissions to do that. As I mentioned during the lecture theoretical part also, that in order to perform some of the functions in operating systems in general, you need administrator or root access. So this is one of the functions that is that requires you to have root access. So in order to do that in Linux, I can do, let me clear the screen first of all. I can do sudo super user do is what this abbreviation is called, and it gives you the root access. So I want to remove LP, so I will do remove module rmmod and the name of the kernel module. It will ask me the password. Once I type the password, it doesn't give me any error, which means that the command has been executed successfully, and this kernel module LP is removed from our kernel. We can check this back by listing all the kernel modules. If we go and see, we won't find LP here anymore, so LP has been removed. So this is how you remove a currently available kernel module from the kernel. So the kernel modules that you believe are not required in your kernel and your machine boots up very slow, this is one of the ways you can improve the performance of your kernel. But obviously you should know what you are removing, and you should know the consequences of that. You have to make sure what you are removing, and you have to make sure you know what you are doing. So it is highly not recommended to do that unless and until you have appropriate knowledge of doing that. So we have removed the line printer from the kernel modules, kernel module from the kernel. We can now reload that. In order to reload a kernel module, what we can do is, there is another command. There are two commands to do that, to be honest. It's insmod, which is insert module. Obviously you need sudo command, sudo privileges for that. Or there is another command which is mod prob, which is also used to insert, add any kernel module to the kernel. I like this command because this command will load all the dependencies. If there is a dependency, then this command will automatically load that module first and then the other module. For example, I mean, my kernel module A depends upon kernel module B. So in order for kernel module A to be in the kernel, it needs kernel module B to be already in kernel, in the kernel itself. So if I run this command, it will automatically check for all the dependencies and load all the required kernel modules for me. So what I'm gonna do is I will load back LP line printer again. So I will write this command and try to load my LP. So it's loaded. I can go back and see. Once you load the kernel modules in the kernel, normally they are at the top. If you see, it's there now at the top. This is what we have just loaded. So these are 2-3 commands which you can use to see the kernel modules loaded in the kernel. We can also see details about our kernel module. So if I want to check the detail of the kernel module, I can do that, and for that I can run this command mod info and the name of the kernel module, and it will give me the details of that kernel module, who created that, what is the license for that, this is GPL license, what is the file name, the path of that kernel module, signature of that kernel module, and all these kind of information. If there is an author to that kernel module, it will tell us about the author as well. So it gives us a lot of information about the kernel module we are working on. And we already know that kernel modules are ways of doing things in the kernel. So kernel actually is a combination of several kernel modules. They can be device drivers, they can be file system drivers, they can be for any commands you want to run. For example, your kernel module might not know something, and you want your kernel to know something. For example, a file extension, you want your kernel to know a certain file extension which kernel doesn't know right now, so you can write a kernel module for that. So whenever kernel sees that that file extension, it loads that with a certain program. So many things you can do with kernel module. So what we're gonna do right now is we are going to create a very simple kernel module in C language, and what that kernel module is going to do, it's not going to be very useful, as it's just gonna print hello world or just a greeting message on the log. And when we remove that kernel module from our kernel, it just displays another message. This is just to show you that what you can do with your kernel module. Well, they are very comprehensive. You can do so many things with the kernel modules, but we are not going to go into a lot of detail. I want to keep it very simple, and I want to align it with what we have done in the theoretical part, so that you actually understand that whatever we have done in the theoretical part, this is the application of that. This is how you can do it. So let's do that. Let's write a small program. If you remember, I showed you the steps. So we have to write a kernel module first, then we load that into the kernel, and it performs actions in the kernel, then we exit that. So first step is to write a kernel module. So let's write a kernel module. I use Sublime text editor. You can use anything you like. So you can even use terminal to write your programs in C or C++ or whatever programs you want to write. You can use a default gedit as well. So it's up to you. You don't necessarily have to use a Sublime text editor. You can use whatever you like. So I'm gonna call this as, let me create first of all a directory. So I will check where currently I am. So I will do a cd document. I'll go to my temp folder, and let me create a directory in the temp folder, and let me call it module. So let me go into that directory. So yeah, so I'm gonna save this file as what do we call it? So let's go to the directory I just created. Let's call it hello underscore kernel.c. You can name it obviously anything you like, and since it's a C program, we want to have an extension C at the end, and I'm just gonna save it. So we need to first of all include all the libraries, necessary libraries. So in C and C++ we do something like that. So for the kernel modules we need these libraries. So init is used for initializing the kernel. Then we need a module library as well for kernel modules. Then we need kernel library for displaying messages on the console. So these are the libraries I require for now. Next what I'm going to do is I have to write a function that just displays something, and I will forward that function to my init method, or init underscore module underscore init API library. So what happens is, if we go back, module underscore init, it will take a function as a parameter, and whatever is happening in that function, whatever action that function performs, this module underscore int will just start that action. So let me write it, and then you'll understand what I'm talking about. So let me create a function, very simple function, and let me call it my underscore init underscore function. And this function is gonna trigger some action whenever my kernel module, which is this one, will be loaded into the kernel, right? So I just want to print something. I will do print k. Now in order to print something in the kernel module, we don't use a typical C or C++ cout directives. We don't do that, because kernel is not there for printing something. It's not there for printing something. So but in order to force kernel to print for us something, we use a special command in C. It's called print k. That is under, if I'm not wrong, under kernel.h, and we use special flags, kern underscore alert, and then we type our message. So I can say this is my first kernel module, and then a semicolon. So what is happening over here is, so I have a special function, is called print k, that is used to print something on the console for the kernel. If it was a regular program, I'll just write printf. Very simple. This is what we do in C. But for console printing of kernel modules, we use print k. And inside this function, I have to pass a flag which is kern underscore alert. There are many other flags available. There is one flag kern underscore warning. There is a flag kern underscore info. What they do is they have different priorities. Kern underscore alert, why I'm using this is it has the highest priority of displaying something. So normally the other flags, if I use kern underscore info or so on, what they will do is they will just log whatever I write right over here. It will log that message in a file. It will not display on the console. Kern underscore alert, what it does is it has the highest priority, and it does two things. First thing, it will display this message on the console, and it will also log this message in the log file also. So that's why I'm using kern underscore alert. Just make sure you don't make mistakes in the syntax of this line. So this is how the syntax is. There is no comma, no semicolons within it. There is a semicolon obviously at the end of the statement, and then I'm just going to return 0. If it's a 0, it means that this function has successfully been executed. If there is some other value, then it means something else. So that is for you to try, for you guys to try as a separate exercise. What happens if we change this 0 to some other positive or negative value? But for now, let's do that. So this is our first function. Very simple function. It's just printing a message and returning the control to the operating system. That's it. Second function I want to write it. This function will be for my module underscore init. So as soon as I enter this method, my kernel will simply display this message on the console. I want to do something also when my kernel module exits or leaves the kernel. So this is for entering the kernel. I want to do something when my kernel module leaves the kernel. So I can write a function for that. I can do whatever name you like, my exit underscore function, and same way I'll just do print k. I do kern underscore alert, and this just print a message exiting from the kernel. Let's put /n for new line also, so that it doesn't get appended to the previous line, and /n, and I'm not returning anything over here, just like that. So these are two functions I have created. These are the bare minimum for any kernel module. You need to write these two functions in order for kernel module to work properly. So an init function for entering the kernel module, an exit function for exiting the kernel module. Right now this program will not do anything unless and until we trigger these functions, right? We trigger these functions. Just like if you go back to Java or C++, if you write a function, it will not work unless and until you call that function in the main method, right? In the main function. So you have to have a main function or a main method where your program starts, right? So if you don't have a main function or a main method, then your program will not work. Although your C or C++ or your Java file is there, the program is written, but it will not work unless and until there is a main method, unless your functions are triggered or called. Now in order for these two functions to be triggered, to be called, we have to use APIs, right? So I want to display this message as soon as my kernel module is loaded in the kernel, right? So what I'm going to do is, there is a special API for that. It's called module underscore int. So this is a default API. These are keywords, these are the key functions, we cannot change them. If you change it to somebody, it will not work. So these are very important in exactly the same way. It has an underscore and they are all in lowercase, so it's important you keep it this way. And inside this function you have to pass the name of your function. So what this function will do is, this is the kernel module function. So what happens is, as soon as this function runs, it will run your function, and this is triggered automatically when your kernel runs, right? So what happens is, what I want to do is, I want to run my function. So what I'm going to do is, inside this function I'm going to put my function's name. So I'll just pass my function's name as a parameter. Oops. So that's it. So, and this will happen only at the beginning of my kernel module loading or registering of my kernel module. I want to do something similar whenever I exit the kernel module also. So there is a function, built-in function called module underscore exit, and this is obviously used when my kernel module exits the kernel, and I want to pass this my other function name, which is my exit underscore function, and semicolon. We save this file and we are done. So this is your whole program, very simple program, just for displaying couple of messages on the console from the kernel. That's it. We have to now test if we need to first compile it and see if there is an error, any compile time error or not. We do that, then we load it into the kernel and see what's going on. Now one important thing over here is, in order to compile this, now since we need to compile our function, and this is a kernel module we are compiling, right? It's a kernel module we are compiling. We do not have a compiler for this. We have to use a default compiler for the kernel modules. So in C++ or in Java, what we do is, in Java we have a JVM which takes care of all the compilation, and in C++ we have their own compilers that take care of everything. But for this specific kernel module, we have to write our own Makefile. So it's very important to write Makefile, because it gives us more control over our kernel module, and we can do whatever we want with our kernel module, however we want to compile it. We can give some extra directions to our kernel module as well. So before the compilers were part of IDE, integrated development environment, we used to create makefiles. It was a very traditional way of compiling any program in C or C++. But now since we have integrated development environments and we have compilers that come separately, we can use them. But for this kernel module in C, we have to go with the traditional way of compiling through a makefile. So we have to write a makefile. So I'm done with this. I have to create a makefile now, so I'm going to do the same thing. I'll just create a new file and I have to write a makefile. Now you don't have to understand a lot about things in the inside this makefile. It's just 2-3 lines of code. So I'm not gonna give a lot of detail about what a makefile is, how it works and so on, because that's not I want you to do. If you want to learn more about makefile, you can just Google it and you'll get to know, because if you know these 2-3 lines I'm gonna write, these are enough for this course. But obviously if you want to learn more about this, you can Google it and you can learn more about it. So let's write a makefile. Makefile is saved by the name Makefile. It has to be by the name Makefile, and it has to be in the same folder as your file which you want to compile, of course. So I'm going to call it Makefile, and it has to be like this. You can do small m as well, but this is the traditional way of writing it. So Makefile here, and I'm going to write this Makefile. So this is how you write the Makefile. So what you have to do over here is, first of all, you have to tell what will be the output of this file. When you compile something, it creates another file, right? When you compile some file, it creates in result another file that is an executable file. So you need to tell over here the name of that file. So I'm going to call it hello_kernel.o. This is normally how you write output files for C. So this is how it looks like. So my C file is by the same name, but it has .c extension. My Makefile will produce for me an output file, which is, the name is the same of that file, but the extension for that is .o for output. Alright, so you don't have to use all here. These are just targets. If you don't want to write all, it's just fine. You can just write the line I'm gonna write now. But it's always good to write it this way because it's more convenient, it's more readable. So what I'm going to do is, I want to make a file that can be compiled. So make is a keyword, -c is a keyword for compiling, and I have to tell over here the headers, right? So if you see over here, if you see over here, I've included some headers, right? I have included some libraries. I need to tell in my Makefile where are these headers? Where can I find these headers, right? So you need to know the path to these headers also. Otherwise, the compiler will not know what these are. So you need to tell them where these files are. So you need to write a path over here. In a traditional compiler actually already knows, because it's also, the traditional compiler is also combination of make files like this. It knows already where your libraries are, so it goes over there and fetch those libraries from there. So what I'm going to do over here is, so I will tell you 2 ways of doing it. You choose whatever you like. So normally you can find out the name of your headers by writing this command. So this is the name of your kernel. So your edition might be different, so that's why it's very important that you know the name of this kernel. So you have to see where what is actually the name of your kernel, and then you can hard code that value over here along with the full path. Or if you don't want to go by this way, you can put a dynamic path, which your compiler will automatically pick up the uname -r, your kernel version automatically, and replace the variables by that name. So you can do that as well, and I'm going to use the second approach. So your headers are normally available over here, -lib -modules / the name of your kernel or the version of your kernel, which is over here. As I said, you can hard code this value, or if you don't want to hard code this value, you can ask the compiler to pick this value automatically. So I'm going to write shell. Why I'm writing shell? I'm asking the shell, the command prompt, to run this command uname, which I just ran in the shell, -r. What this will do is, this will do exactly what I did over here. It will run this command and return the name of your kernel. And it will return the name of the kernel, then /build. Right? This is where now this thing will be replaced by the name of your kernel, right? So this whole path will be the path of your kernel along with the headers. Now this is where your headers will be found. Now compiler knows, okay, I have to go here and fetch the headers which were included in the library in the program from this path. Then I have to provide some I have to provide the subdirectories as well. So what I'm going to do is I will tell the compiler that fetch that file, this file, from my present working directory, right? It will take this from my present working directory, which is, if you do now, is this one, right? This is where my file is. So I need to tell the compiler where my file is. So by this path I can tell it, okay, this file is available at this path. And what these files are, these are basically modules. So that's it. This is what I'm going to write. That's it. You can write some extra code, which is always good to clean up as well. So for cleaning up, there is another directive which is like this, which is used for cleaning up, and it's pretty much same. I'm just gonna copy and paste this one and replace that thing with clean. So you just have to replace modules with clean. What it will do is it will automatically clean if there are some garbage available. If you forgot to remove your modules, it will try to clean that up automatically, right? Because we cannot keep on creating kernel modules and they stay in the kernel forever, and we forget to remove them, and the kernel size will keep on increasing. So it's always a good idea in the Makefile, try to make sure that if you forgot, at least the Makefile will clean for you the kernel module. But it's your responsibility as a programmer to remove the kernel modules that are not required. So this is the Makefile, very simple. I tried to explain all these parameters, all these lines, so that you understand what's going on over here. So I hope it's pretty clear now. If it's still not clear, you can always drop me an email, but I would suggest you, if you don't understand this, try to Google it somehow and try to create other Makefiles with variations here and there to see how it works. And but I won't ask you to do it too much. If you know what's going on in this file, that is just enough. You don't have to do anything else. So we are done with this. So we have created our file, we have created our Makefile. It's time to compile our program. So let's compile our file which we have just created. So for that I'm gonna just write make, M-A-K-E, and it will start compiling my file. So you have to make sure that you are in the directory. Since we have an error, I missed a semicolon maybe. Let's see. Oh yeah. So I missed a semicolon over here. Save it. Go back to terminal. Try to run the same command, and it will start compiling. So it seems like it has compiled without an error. This file is now ready for us. So if you go to this module, first of all you have to make sure that you are inside your directory where you are working. So you have to make sure that this is exactly the same directory where you created your Makefile. This is one thing. Second thing is, you have to make sure that in order to run a Makefile, you don't have to write Makefile. No, the command is make, just like what we had over here, make. So what this command does is, it basically is a utility in Linux. It's a built-in utility in Linux. So as soon as you write make in the directory you are, it will try, this command will try to, or this program will try to find Makefile in that directory, which is this file, right? So as soon as it finds this file, it will start executing this file and perform all the executions over here. So our execution over here meant that we wanted to create compile our kernel module, which was written in C. This is what we told, and I already explained it to you, and it's all done. So if our file has been compiled. If we go and see our folder now, you can see there are so many files inside it, right? Our original file was only hello underscore kernel.c, and then we created a Makefile. These were only two files we created. If you see now, we now have a .o file also. This is what we mentioned in our output. So for us, our output file is created also. And if you see, we have, this is the most important file, hello underscore kernel.ko file. This is the kernel output file. This is the file we're gonna run now. This is the executable file we're gonna run now, and this is what exactly what we needed. So if you are compiling a traditional conventional C file, you won't see that many files inside. But since we asked our Makefile to build a kernel output file using this command, that's why it has created for us the traditional output file for C also, which is this file, and it has also created the other files along with all the dependencies we needed for this file. So we have now our hello underscore kernel.ko file. So this is our kernel module which we have just created. It's an executable kernel module we have created. We have to now insert this kernel module into our kernel, and you know how to do that. We just did that with LP, if you remember, line printer, and we are going to do it again for our kernel module now. So what we're going to do is, I'm going to use insert, let's use sudo insert mod command, insmod command, and then the name of my kernel module .ko. It will ask me the password. I will put the password, and there is no error, which means that this kernel module is now registered or loaded into the kernel. Now we know that as soon as this kernel module is loaded into the kernel, we should see a message, this one, which says this is my first kernel module. So where is that message? I don't see anything, right? Now, as I told you that this is not a traditional C or C++ program which will show you a message over here. It is because it's using print k. It's not using printf, it's not using cout, it's not using system for Java. So what it does is, it has created an output on the console, but that's in the kernel console, and it has logged those this message in the log files as well. So in order to see that, in order to see the kernel console, we have a special command, we call it dmesg, dmesg, and if I do that, you can see that I have this message at the bottom. This is my first kernel module, which means that our kernel module ran successfully inside our kernel. So it's red because we used this flag kern underscore alert, which is normally to alert. This is just a way of alerting the system administrator, just to show them that there is an alert. So if you see that this is already there, right? So it means that our kernel module was successfully loaded into the kernel, and it was executed by module underscore init as well. So this is what we wanted. Many congratulations. This was your first kernel module you created, and you have successfully created that. You have successfully loaded that into the kernel module, and it's working absolutely fine. And we can see that it's working by using the command dmes. It will show you all the messages in your kernel log in the kernel module. So if you type this, it will show you everything kernel was showing. So another way is to use the log file, and it will show you, I'm using the tail command, which will show me, I think, last 10 inputs in my syslog. So if you see that in my syslog, this is my system log file where my outputs on the kernel are written. So you can see that my output is also there in syslog file. So if I was not using kern underscore alert, it would not show me an output on the kernel module. or at least at least another flag which has enough priority to be shown on the console. If I'm not using that, then it would just load my kernel and display that message. It will not display that message on the console, it will just write that message on the log file just like that, and I would not see this message over here. So you should use a kernel flag. We normally call it kernel flags that have enough privileges to show the messages on the console as well. So yeah, we have loaded our kernel module successfully into kernel. Now as I told you, it is very important as a programmer, as a operating system programmer, that whenever you are loading kernels into the kernel modules into the kernel, it's your responsibility as a kernel developer or as an operating system developer and programmer to remove those kernel modules that are not required. And this kernel module is definitely not doing anything. It's just gonna increase the size of the kernel, and it's just gonna stay there for forever doing nothing. It's not useful at all. So it's always a good idea. So once you are done with your kernel modules, if you think they are not needed in future, you should remove them. It's extremely important that you do that. So, and you know how to remove our kernel modules, but before we remove that, let's see the info for this. So we know how to see the info and the name of our kernel. Hello underscore kernel. So this is the details of our kernel. So this is where the kernel resides. We know the path of this kernel. This is the source version. This is randomly generated by the kernel. Name of the kernel is this one. This is the version of the kernel, and so on. So if you see, the details of this kernel are not as much as we saw for LP, because LP had other details also. Because we did not enter any details, these are just default details that were picked up by the kernel itself. So in order to write more details of it, what is the license, who is the author, also the description of this one, you have different functions for that. So we have functions like author, we have function module underscore author, then we have functions like module underscore description as well. Then there is a module underscore license as well. So you can do that. You can write the name. So whenever you write a kernel module and you give it to your friend, you at least have your signatures into that. So I leave it to you guys to modify this code and add a license to it, add a author to it, and add a description to it. So I leave it to you. That is kind of your homework. It's not an assessment, so it's not marked, but I would highly suggest you guys to do that. It will give you more motivation when this runs. It will give you more understanding of how kernel modules work. So I would highly suggest you to do that. Alright, so we have reached up till here. Now the last thing is to just remove this kernel module from the kernel. So we know the command for that. So it's sudo rm mod, and we need to remove our kernel module from the kernel, and we do this and it's gone. So it won't be there. We want to see the log also. If you see, I just went into the log. It's showing me the last 10 logs, and you can see the message we wrote for our output whenever exiting from the kernel. So you can see this message. Actually it was there in my syslog file, and you can see this message also in the message, which is the kernel console. So you can see that in kernel console we have both our messages over there. So exiting from the kernel is also there. So it means that both our functions, my init function and my exit function, which we passed into module init and module exit, they are both working fine, exactly as we expected them to. So this is how your kernel modules work. I hope you understand what's going on here. I hope you understand the basics of kernel modules. I hope you understand why exactly do we need kernel modules, and different applications of these kernel modules. We ran several commands for specifically for kernel modules, like ls mod, then we did mod info as well, we did ns mod, then we did mod prop, we did rm mod as well. So all these commands, try to get yourself familiarized with these commands so that you understand which command stands for what and what it actually does. So, and again, as I said, it's highly recommended that you run this with your variation of code. Make sure you run this. You know, it's because I have gone through all this student phase, and my recent experience has been all learning. So I have been learning throughout, and this is what I have understood, and it's applicable to everybody, right? So if you see code in front of you and somebody is explaining the code to you, sometimes you do understand the code, and when you get back to that code, you might still understand that code because the code is written in front of you. But when you start writing code yourself, it's a different story altogether. It's a different story. Even if you memorize the code and start writing the code, it's altogether a different story. You will know that how doing it yourself will help you so much in learning. And these codes, trust me, it doesn't work like this. I mean, all the language, be it a human language, be it a programming language, if you don't practice it, it's not gonna work. I was in Japan for 8 years, and in order to survive over there, you need to learn Japanese language. So in my first few months, it was very difficult for me because they don't know English much, and in my university, all of my colleagues, they were Japanese, and I knew no Japanese, so it was very tough. And then when you get along with the people, you start learning the culture, you start learning the languages, it becomes easy for you. Same applies over here to programming languages. I mean, you have to make sure that you practice it. If you don't practice it, you lose grip of it. Even if you are a master of a programming language, and you let go that programming language for a couple of months, when you come back, your hands will start shaking. And so it's very, very important you do that. Even with small variations, just try to do this code yourself just by changing this message inside. Try to start with the by changing this message and run the code. Try to create a Makefile with different variations. Try to create this program with different variation. As I said, as an assignment, once you are done with the basics of this code, writing kernel module, changing these strings, this string as well, then obviously I would ask you to obviously do other things as well. So these are few things that you should practice at home. I'm sure they will give you encouragement when you start writing your own kernel modules. But before you jump there, these are few things that you should do as practice. So the first thing is, let me go back to the file. If you remember, I asked you to try to return something else from here. Instead of returning 0, which is always success over here, why don't you try to return -1 or try to return 1 and see what happens. So try to do that. So first thing is try to change the return value from init, my_init function, and see how it behaves, what happens to your program. Does it change anything in the output, or does something else happen over here? So this is first thing that you can try. Second thing is, what you can do is try to add a license to it. So second step would be to add a license to your kernel, module. So try to add a license to the kernel module. For that, I want you to go online and see how you can do that. It's very simple. You just have to use module_license. So try to do that. Third thing is, what you can do is try to add an author to your kernel module. Add details of or add an author. Simple. Add an author to your kernel module. And a last thing what you can do is you can add details or description of this kernel module. So once you are done doing these three things, you have to separately try this first of all. Once you are done understanding what is going on with the flags with different values, how the output changes or not change, after that you should try these three things. So once you are done with these things and you have recompiled your kernel modules and then you loaded that into your kernel, what you have to do is you have to just check mod info. So you have to do mod info to your kernel module and see how it shows you the description. If you remember, the last time we checked it, it didn't have too many things inside its description. So last time we ran it, it was having something like this: not too much information, no license, no author, no description at all. So if you add those functions to it, you will see these things changing. So try to do that and see how it works. And yeah, that's pretty much it for this. Try to do these things, and this is the only exercise for kernel module, if I'm not wrong. We might run into kernel modules again, but that's after I think 9th week or 10th week. So for now this topic will be very quiet, so we are not returning to this topic for now. But yes, I would highly encourage you guys to get used to Linux, some basic commands in Linux. Also C, make sure you understand C. I really like the approach of some of the students. They approached me asking what I can do to learn this course even before this course actually started, which is very good, because they were warming themselves up. They wanted to get started with this course. So I advise them to get used to Linux, basic Linux commands, and see how can we compile C code, how can we compile C++ code in Linux. So this is what we're going to do in the next class. We are going to write some C code. We will create some new processes. We'll split those processes. We'll create parent processes, child processes. Obviously before that we learn about what process is, why we use processes in Linux and in general in operating system, and then how can we play around with processes. I hope you like this approach of theory versus theory plus practice. If we don't do practice, I myself don't believe that it's gonna help too much. Yes, many of the concepts of operating system, they still are theoretical, you should know that, and they are coming for sure. But I will try my level best to have exercises, at least one exercise in each of the classes. Fine, we can keep the theoretical part, that's okay, but at least I will come up with something so that you can see things happening in practice. So that's it for now. That's it from my side for this lecture. If you have any questions, as always, please drop me an email. If you don't understand anything, please ask me a question. I would love to answer your questions. The problem is, if you don't ask questions, then I will start asking questions in exams, which might be difficult to answer. So please ask any questions. Try to do your own research as well. It's always a good idea to do your own research. And then even then, if you are not able to understand anything, please drop me a message through email. I'm gonna announce my office hours as well, hopefully soon. So please look into those office hours, and I'll make sure I'm available in those office hours on either Blackboard or Zoom. I'll create virtual office hours maybe on Blackboard, and you can join me in those office hours if you want to understand anything, if you have any other queries. So that's it from my side, guys. Have a nice day, and drop me an email if you have any more questions. Thank you. Bye bye. Have a nice day.